Today we're going to talk about the Pythagorean Theorem. This is Pythagoras down here in the corner, a little snapshot of him. And I wanted to give you a little bit of background. Pythagoras was a Greek philosopher and a religious leader. He came up with the idea of odd and even numbers. And he said that odd numbers were masculine and even numbers were feminine. If you have any ideas why, definitely bring those to class. We'd like to hear why you think odd numbers were masculine and even numbers were feminine. On the other hand, the unit that we are discussing with radicals, he came up with square numbers, hence the name square root. And also, he developed the theorem, a squared plus b squared equals c squared. And this is used to solve right triangles. Now, this is not the only things he has done. Look on Wikipedia or just Google Pythagoras and you'll see a whole slew of things that he has done. Mathematical genius, we would say. But this is the theorem that we are going to focus on today. So make sure you have that written down. A squared plus b squared equals c squared. Now, used to solve right triangles and only right triangles. Right triangles have a certain criteria that makes them a right triangle, and it is a right angle. A right angle, indicated by a little box down here, says that this corner alone is 90 degrees, and that's what makes it a right triangle. So even furthermore, we need to label the right triangle. This will help us out with the particular theorem. The longest side in a right triangle is called the hypotenuse, so you'll hear this word quite frequently. The other two sides, well, we simply just call them legs. So we have hypotenuse and we have legs. Again, the hypotenuse is the longest side of the right triangle. The hypotenuse is indicated by the term or the letter C. So this is your C from that theorem. And A and B, since we're adding these, they're interchangeable because think about it. What's 2 plus 3? And then what's 3 plus 2? So it doesn't matter which way you put them, they're still going to come out, you're still going to come out with the same answer. So this leg could be considered A and this one be B, or vice versa. Let's hop to the first problem. So we have this right triangle. You may want to pause the video and draw this out and then hit play when you're ready to go. So we have a right triangle here, and what are we trying to find? Let's go ahead and write our theorem down. A squared plus b squared equals c squared, because this is the formula that we use to solve right triangles. So what are we looking for? We're looking for the hypotenuse. Now, also said that it was the longest side, but I'll give you another hint. It's always across from the 90-degree angle. So now you've got two ways to identify what the hypotenuse is. It's the longest side of the triangle. Furthermore, it's across from the right angle. Because sometimes the sides look pretty close together, so it's hard to indicate which one is the longest. So this is a good rule of thumb, across from the right angle. All right, so this is what we're looking for. We are looking for our C. So this would be a leg, and this would be a leg. So these are our two legs, and we're going to plug them straight into the formula. One leg is 3/5, and it says that we take that leg and we square it, plus we take the other leg, which is 4/5, and we square it. And we take the length of the hypotenuse, we don't know what it is, and we square it. So don't forget to put your squares on there because those are important. Now let's work this out. 3/5 squared, 9/25. Now let me back up a second. Some of you are going, what just happened? Remember that a square indicates how many times you multiply what you have. So really and truthfully, it looks like this. 3/5 times 3/5, and just go across. 3 times 3 is 9, and 5 times 5 is 25. So there's your little background on how I came up with this so quickly. So let's try 4/5 squared. We've got 16/25. We're still looking for the hypotenuse. We don't know what it is yet. Now we've got two fractions. Remember, when is the only, or how is the only way that you can add and subtract fractions? You're right, they have to have a common denominator. And let's check out our denominators. We have 25 and 25. So we are identical here. So we can add these up. Let's add the numerators together. 9 plus 16 ends up being 25. over 25 equals c squared. Let's reduce this fraction. What is 25 divided by 25? 1. So your fear probably of looking at this first example with these fractions actually didn't turn out that bad. But look, we're not finished at all, and some students will stop right here, but we are not finished because we want to know what the hypotenuse is, not what the hypotenuse squared is. Your last step in solving the Pythagorean theorem is always to take the square root, because let's think about it. What undoes a square is if I square root it. What you do to one side, you have to do to the other. So the square root of c squared, that's an even exponent. It's considered a perfect square, so they kind of cancel out each other. And we have c equals, what's the square root of 1? 1. We have found the length of our hypotenuse. It is 1 meter long. Let's go look at another one. This was finding the hypotenuse. What happens if I'm actually looking for a particular leg? And furthermore, what if it doesn't come out to a perfect whole number? Okay, so here we go. Find the length of the missing side and leave your answer in radical form. We are dealing with a right triangle. A squared plus b squared equals c squared is the formula that we use to solving right triangles. Now, let's identify. Where is the hypotenuse? I hope you said 12. It is the longest side, and it's across from the right angle, so that's how I know I'm correct. So this is going to go in for the letter C, 12 squared. What do we got? We got two legs here. One is 10 and one is unknown. So I'm going to put 10 for A. And since I don't know this side, I'm going to keep the letter B. This is what we're actually going to solve for. So let's roll with it. 10 squared is 100 plus b squared equals 12 squared is 144. Now let's look at this equation. Let's think back in the beginnings of solving an equation. If we're trying to get a particular letter by itself, we have to move everything else away from it. Right now we have 100 that's being added to it. We need to move this 100 to the other side, and we are going to do that by subtracting that number. So now I have b squared equals 44. Last and final step is to actually find out what b is, not b squared. We want to know what b is. So take the square root of both sides. So I've got b equals the square root of 44. Now let's check our directions. Find the length of the missing side and leave your answer in radical form. Simplest radical form that I might add. So we have to simplify this, and we know how to simplify this. Let's think about it. Simplifying a radical, you have to find two numbers multiplied together where one of them is a perfect square. Two numbers multiplied together where one is a perfect square. How about 4 times 11? 4 times 11 will give you 44, and 4 is our perfect square. The reason that we're choosing these perfect squares is because, well, we know the answer, and you guys know this just as well as me. What is the square root of 4? You're right, a normal number of 2. Don't you dare put that radical sign back on there. It's just a normal number of 2. And all we have left in the radical is an 11. So we have simplified this as far as we possibly can go. So we have that b equals 2 square root of 11. All right, so we've solved the Pythagorean theorem two different ways. We've looked for a leg, and then up above we've actually found the hypotenuse. Now, this is not the only thing that you can do with the Pythagorean theorem. You can do some things like this. Let's talk about it. In the examples above, I told you that you were dealing with a right triangle, even had a picture drawn for you. And we used the Pythagorean theorem to find the missing side length. On the other hand, you can use the Pythagorean theorem to determine whether the given side lengths are the side lengths of a right triangle. or it could be another type of triangle. We'll get to that in geometry, discovering the other types of triangles, like obtuse and acute triangles. So let's just focus on right triangles. Let's determine if these side lengths, because we don't have a picture to look at, we don't see a magic little box down in the corner indicating that it's a right triangle. We've got to work for it. So we've got a side length of 11 feet, 6 feet, and 8 feet. Now, this is what I would say whenever you're just given a list of side lengths. Use your knowledge about how the hypotenuse is the biggest side. It is the largest side, so let's think about it, guys. It's going to be the biggest number. So if we are going to figure out if these are the side lengths of a right triangle, this is what we want to know. We want to know, do the legs actually equal? Do they actually equal the hypotenuse length? Does this side equal this side? And if it does, then we do have a right triangle. If it doesn't, then we have another type, and we'll discuss that a little later. All right, so let's look at our numbers here, 11, 6, and 8. What is the biggest number? 11. Which letter is this going to go into? C. Okay, so this is what we're trying to figure out. 11 squared. And let's take our other two numbers, which are 6 and 8. So I put them in numerical order. The largest number will be the biggest side, which is known as the hypotenuse. So let's figure this out. Let's see if this side over here, if it does equal. All right, 6 times 6 is 36. 8 times 8 is 64. And 11 times 11 is 121. So we have a question mark here. Does it equal? Well, let's keep going. 36 plus 64 is 100. And we have 121 on this side. So my question to you, does this side equal this side? Absolutely not. So these are not the side lengths of a right triangle because it didn't equal. It has to equal in order for it to be a right triangle. Let's look at one more. We've got 3, 4, and 5. Now these are in numerical order already for us, so that helps us out a little bit. A squared plus b squared equals c squared. Again, to see if these are a right triangle, question mark, then we need to see if this side equals this side. Let's plug these values in. Where's the biggest number? Here. And that goes in for which letter? C. So we have 5 squared. Question, does it equal? Let's take our other two values and plug them in for our legs. And let's work. 3 squared is 9. 4 squared is 16. And 5 squared is 25. This is the big question here. Let's keep going. 9 plus 16 is 25. We are looking good. Question to you. Does the left side equal the right side? Yes, it does. So what does this tell us? That these lengths, 3, 4, and 5, are of a right triangle. So to sum it up, we can use the Pythagorean Theorem to find missing side lengths of a right triangle, and furthermore, we can determine, without even seeing a picture, a diagram, or anything, if the side lengths that we have at hand are of a right triangle. Hope you like the Pythagorean Theorem, and look him up on the internet. See what you can find. Bring that information to us. He's an interesting guy.